All right, this is the beginning of part two. So the first part's pretty easy. We're just going to match these up. Now, I'll tell you right now in the exam, you're not going to have any matching or anything like this. This is just kind of a simple review of this. And so what we're going to do here is we're going to review the y equals mx plus b. And so if you remember, m is the slope and b is the y-intercept. So if you think about it, if you let x equal 0, the equation is going to be equal to whatever b is. So that's where you kind of look to start on the graph, and then from there you can kind of use your slope, rise over run to help you with that. So on this first one, number 19, it's saying my y-intercept is going to be at -2. And really I only have one of those. That's going to be d down here. But just to review slope, this is 3 over 2, so up 3 over 2. That's what gets me to my next point, and so on, up 3 over 2. So we can see that D is going to go with number 19. 20 says my y-intercept's at 3. Okay, so we can see that that's going to be right here. My slope's -1. So basically it's like down 1 over 1, down 1 over 1. Just tells you the rate of change of y as x increases. So every time x is increasing, y is decreasing by 1 unit. So let's see, that'll be C. Now 20, you'll notice I don't have an x there. Okay, so what's going on there is basically my slope is 0. So I have a 0 slope. And so hopefully we recognize that that's going to be a flat line. Okay, and so it's going to be a flat line at this fraction right here, which is slightly a little more than 3, so 3 1/4. So that's going to be right here on F. So you can see it does have a y-intercept right there, and then the slope is just flat going across. So that's going to be F. 22, so I'm going to have a slope of 1. This time my y-intercept starts at 1/2. And that looks like that's going to pair up with A right there. So it just keeps going up 1 over 1, up 1. So this time my slope y increases by 1 every time x increases by 1. So let's see, that'll be A. And then x equals -2. So this time the y is missing. And so this time this is x equals -2. And there is no variation, or there is no y variable there. So it's an undefined slope, and so that's just going to be b right here. So see, all the x values are -2, -2, -2. So that's what x is there. So let's see, that'll be b. And then the last one, 24, we have a slope of -1/2, and we start at 2 on the y-axis. So this time our slope was -1/2, so down 1 over 2, down 1 over 2, and so on. So that's going to be E right there. Okay, so that was a nice little review of this. Okay, so now what we're going to do is it says list the slope and y-intercept, then graph the line. So the difference here now is you're going to have to solve for y. So on the previous page, we didn't have any problems with that. They were all fairly simple. So we're going to go ahead and solve for y. So I'm going to start by subtracting by 3x on both sides. So that cancels that out. So I'm going to be left with 2y equals, and what I'm going to do is put the 6 behind this. It's personal preference. So it's a +6, so I tack it on as a +6. And I'll divide everything by 2. So that cancels out. So I'm going to be left with y equals -3/2 x, and then 6 divided by 2 is 3. Okay, so remember the slope-intercept formula. My slope is -3 over 2. Do not bring the x with it. You're going to lose points if you do that, okay? And then the y-intercept, that's easy because if you let x equal 0, then y is going to equal 3 right there. And so right there, that's the y-intercept on the graph right there at 0, 3. Now the slope is -3 over 2. So down 3, forward 2. Down 3, forward 2, just to find an extra point. And now we'll go ahead and graph that. And there you go. So I used the slope and y-intercept to graph that line. All right, the next one, we're going to find the x and y intercepts and then use that to graph it. Okay, so by definition, if I want to find the x-intercept, I'm going to let y equals 0, because that's the only way I can land on the x-axis right here, is if y is 0. If y is anything else, I won't land on the x-axis. So this one's pretty easy. So x minus 2 times 0 equals 8. And then this just turns into x minus 0, which really doesn't affect much. So I'm going to get x equals 8. So my x-intercept is going to be at 8, comma 0, which unfortunately is a little off my graph, but that's okay. We'll just do our best. So you shouldn't have that issue on the exam. You'll be fine. But this is just a little off the graph, okay? And then let's see, let's try the next one. So if I want to find the y-intercept, this time we'll go ahead and let x equal 0. So I'm going to have 0 minus 2y equals 8. So that's just kind of silly, so I'm just left with negative 2y equals 8. Then we'll go ahead and divide both sides by negative 2. So that should leave me with y equals 8 divided by negative 2 is a negative 4. So at 0, negative 4. Right down there. And then we'll go ahead and connect the dots. So let's see. And let's see, clean that up a little bit. All right. All right, so that kind of reviewed right there, finding x and y intercepts, and then we just went ahead and used those points to help graph on that one. All right, so the last part we're going to look at is when you're given information about the equation and you have to go ahead and come up with the equation. And so I'm going to want all the answers in slope-intercept form. So y equals mx plus b. So I want all the answers to look like that. Okay, so to find this, we're going to be using this formula. Y minus y1 equals m times x minus x1. And so we're going to take the data they give us. Hopefully we need a point and we need a slope. We're going to plug those three things in. And that's why this is called the point slope formula. You need a point, you need a slope, and you can solve for y, and there you go. So looking at this right here, we'll go ahead and let this one be x1, y1. The slope of negative 2, so obviously that's my m value. So here we go. So we're going to have y minus 10 equals negative 2 parentheses x minus 3. And this one's pretty easy because we're not having to deal with fractions or anything. So I go ahead and distribute. So let's see, we get y minus 10 equals negative 2x plus 6. And then we'll add 10 to both sides, and I will be done with this one. So that cancels out. So I end up with y equals negative 2x plus 16. And it's pretty easy to verify that this is correct because it does have a slope of negative 2. I can see it right there. And if I plug in 3 for x, that would give me negative 6. Negative 6 plus 16 does equal 10. So if I were to let x equal 3, I could see that y would equal 10 once I do the arithmetic. Okay, so like I said, that one's actually considered to be an easier one. Okay, so we'll go ahead and try a couple more where maybe they're a little bit more challenging. So looking at this one, so let's see, that'll be my x1, y1. There's my slope again. Let's scroll up so I have plenty of room. Okay, so y minus 3 is equal to 2/5 parentheses x minus a negative 4. Okay, so I got to deal with the double negatives right there. So we'll clean that up. So y minus 3 equals 2/5, and then I'm going to have x plus 4. Okay. Now I'll go ahead and distribute the 2/5 to both of these. So now I'm going to have y minus 3 equals 2/5 plus, and so when I multiply this, I got to do 2 times 4 is 8, and 5 times 1 is 5. Oops, don't want to forget my x right there. Okay. Okay, so When you multiply fractions, it's pretty easy. You just go ahead and multiply 2 times 4, 5 times 1. Okay, this next part's a little bit more challenging, so we're going to add 3 to both sides. And so what I'm going to have to do here is I'm going to have to get a common denominator so that I can simplify those constants right there. So what I'm going to do here, so let's see, I got 8/5. I'm going to go ahead and take this this 3, and I'm going to manipulate it by basically multiplying by 5/5. And so what that does is it changes that 3 into a 15/5. It's the same thing, 15/5, still 3, but now I have common denominators so that I can add these two parts together right here. So my final result should be y equals 2/5 x, okay? And then when I add the 8 and the 15 together, that should give me 23/5. Okay? All right, so I think we got one page to go. All right, so this one, the difference here is this time you're just given 2 points, okay? So to do the point slope formula, I need slope first. So I actually need to go ahead and find my slope. So let's see, we'll let this be x1, y1, and x2, y2. Okay, so to find your slope, you take the differences of the y's. So let's see, -4 minus -1 all over 3 minus -2. All right, so I got some double negatives I need to kind of clean up. So -4 plus 1 over 3 plus 2. So I'm ending up with -3/5. All right. All right, so now that I have the slope, I'm ready to go. So use this, and it really you can use either point for your point slope. So I'm going to go ahead and write down the formula real quick. So y minus y1 equals m times x minus x1. So really you can use either point. I'll just use the first point. The numbers are smaller, whatever. It's not going to make a difference in the outcome. So let's see, y minus -1 equals -3/5 times x minus -2. So I have to deal with these double negatives, so we'll go ahead and clean that up. So let's see, I'm going to have y plus 1 equals -3/5 times x plus 2. And so I am going to go ahead and distribute here and here, and I put that 2/1 just to kind of help with the multiplication process. So let's see, we get y plus 1 equals -3/5 x, and then when I multiply -3 times 2, that's going to turn this to a minus. I'm going to have 6 over, and then 5 times 1 is 5 right there. Okay, so I just multiplied the -3/5 to the x and the plus 2. So it caused both of these to become negative, right? And then the last thing you got to do is add that 1 to both sides. So once again, I'm going to manipulate that 1 right here. What we're going to do is we get y equals, so I've got the -3/5 x. I've got the minus 6/5, and then I have a plus 1, but what I'm going to do is I'm going to turn that into a plus 5/5, okay? 5/5, same thing as 1, okay? So same thing, just manipulating it. Okay, so now you got to be careful. You're going to add these together. So you have a minus 6/5 and a plus 5/5. So you really just focus on the numerator. Since the denominators are the same, just do this operation right here. So we're going to end up with y equals -3/5 x. So -6 plus 5 will take you to a -1. So it's going to be a -1 and then all over 5 right there. And there you go. Okay, last but not least. Okay. So on this last one, move this over a little bit so we can see it. Okay. It's going to be kind of hard as I go through this. I'm just going to have to keep scrolling up and down to kind of answer the questions here. But when you look at this, you'll notice that there's 11 parts to this. So this question is going to be worth 22 points. Okay, and so you can see this is actually from an old exam. I put it on the review. So you'll have something identical to this. You'll just have a different graph down here. Okay. So looking at this graph, it asks for the domain. And so as I go from left to right, it looks like it goes from -6 and makes its way to the right indefinitely. So if there's not an open circle, you assume that that point's included. So our domain here is going to be from -6 to infinity. Okay. Now, when we look at the range, you want to see how low and how high it goes, right? And so let's see, we start out right here, y is 0. Then y dips all the way down to -4. And then it goes all the way up to +5, it looks like. And then it comes back down and then just goes out and it doesn't go up or down any further. So the range is going to be from -4 to +5, and we'll include both of those endpoints. So from -4 to +5. Okay. X-intercepts. So you can see it touches here and here. And you can list them as ordered pairs. I'm just going to use set notation. So I'm just going to say when x is -6 and when x is -2, and I can just leave it like that. Okay. Don't put parentheses around it though, because then you're talking about the point right here, -6, -2. Okay. So those little brackets will indicate that, or braces indicate that you're using set notation. All right. Y-intercepts right here at 4. Once again, you can just put a 4 if you want, or if you want to, you could, put an ordered pair. So it's up to you. Okay, the next part is asking you to use the function notation. So f of -4. So you go to f of -4 and you can see that, oh, that's weird. It lines up with -4. So you plug in the x value, but you return the y value for that ordered pair. So that ordered pair is at -4. -4. So we'll go ahead. That's just -4 is the answer. Okay, the next part is asking which interval is the function increasing. So remember, you got to do this from left to right. So from left to right here, it's decreasing because you focus on what y is doing. That tells you whether it's increasing, decreasing, or constant. So it's decreasing, 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 and then all of a sudden it increases from here to here, and then it decreases, and then it stays constant. So the only increasing interval that I see is from -4 to -1. And we always use parentheses on this. So from -4 to -1. So you basically give the domain for which the range is increasing in this case. So the range is increasing. And so you look from left to right. Okay, decreasing. It looks like we're going to have a couple intervals. We're going to have 2 intervals for that. We're going to have one from here, from -6 to -4. So I'll go ahead and write that down. So from -6 to -4. And you can say and, or if you want to, you can put a union, however you want to do that. Okay. Also, it's decreasing from, it looks like, from -1 to +1. So then from -1 to +1. Alrighty, so then the last part's constant. So that's where we're not increasing, decreasing, or any of that stuff. And so that's going to be right here from 1 to infinity. So that's going to be from 1 to infinity. Okay, have a couple more questions up here. So this one right here says state the values of x for which f of x, basically saying for when y is less than or equal to 0. So you're looking for when the y values are 0 or negative. So 0 or negative. And they want us to give the x values for when that occurs. And that's this part right here, this U-shaped right here, okay? Because all these y values are negative right here, right? So it's going to be from when x is -6 to when x is -2. So this time we actually need to use a bracket here. So from -6 to -2 bracket. And so you're basically giving the domain for which the y values are less than or equal to 0. Okay, so if it would have just been less than, then we would have used parentheses because then we wouldn't have counted 0. But since it has the equals to, we count when the graph is equal to 0 also. Okay, last two parts are going to be about finding the local. First is going to be the minimums basically. So you look in a subset if there's any subsets of the graph where there's a lowest point, okay? And that's going to be right here. Right here there's a dip in the graph. And so we're just going to list them as ordered pairs just to make life simple. So that's going to be at -4, -4. That's a minimum in the graph, a local one, right? So there's just a little dip in the graph, okay? So then the next part says to give any local maximas, so any little maximum parts, and you've got one right here. Kind of comes up and peaks and then comes back down. So there's a highest point, right? And so that highest point looks like it's at -1, 5. So that's at -1, 5. So there you go. All right. So that's what you need to know for Thursday. Good luck.